So, tutorial sheet question 3. An AM double sideband broadcast station transmits an average carrier power output of 40 kilowatts and uses a modulation index of 0.707 for sine wave modulation. So we have to calculate three things. But first of all, let's pull out of that question the useful pieces of information. So the first bits of useful information is that it tells us what the carrier power is, and that's 40 kilowatts. It also tells us what the modulation index is, 0.707. So that's the information that we need, and that's all the information we've been given for the question. First of all, we need to calculate part A. What is the total average output power? So for that, we need to recall the equation that governs that. Where PT is equal to PC 1 plus m squared over 2. We have all the bits of information that we need. We know that PC is 40 kilowatts. We know that m is 0.707. So if we work that out, we get total power of 50 kilowatts. Part B asks for the transmission efficiency. Now the efficiency is defined as the power in the sidebands divided by the total power. So that's equal to total power in the sidebands is PC m squared over 2. Total power is PC 1 plus m squared over 2. And again, relatively straightforward. We know PC cancels and we know the value of m, so we can work that out. And that gives us a value of 0.2. or 20%. So A and B are relatively straightforward. Part C requires a little bit more thought. And it's asking for the peak output voltage if the antenna is represented by a 50 ohm resistive load. So what we're essentially saying is our voltage, we have a voltage going into here and we have some resistive load which is equal to 50 ohms. And how much? There's going to be a certain amount of power dissipated into this resistor, and we need to work out what the peak output voltage is. So if we go back and look at the standard form of our AM equation, what we get is VC 1 plus m sine omega m of t sine omega c of t. So that's our standard form. Now to work out what the peak voltage is, we need to know what is the maximum voltage that this could ever be. Well, the maximum voltage of a sine wave, or the maximum value of a sine wave, is 1, and that one is also 1. So the maximum is going to be VC 1 plus m. Well, we know m. What we don't know at the moment is VC, but we can work out what VC is from PC and the fact that we're dissipating this power in a 50 ohm resistor, because the equation that relates PC to VC is that. So we've got VC squared over 2R. So if we rearrange that equation, we get VC is equal to the square root of PC times 2 times R. And that's equal to 2000 volts. So our carrier voltage is 2000 volts. So what we need to do is put this value back into here and say that our peak voltage is equal to VC1 plus M equal to 2000 1 plus 0.707, and if you work that out you get 3414 volts.